For ages, people have tried to make valuable materials, such as gold and diamond, out of other more common, such as carbon or P. In fact, the element phosphorus was discovered by pure accident by Henry Grant while trying to distill gold out of urine. Alchemy, a medieval practice concerned with finding methods to purify, improve, or transform matter in order to create valuable elements out of ordinary stuff. One of the main aspirations of alchemy was to convert base metals, such as lead or iron, into noble metals, as gold or silver. For many years, alchemy was one of the most intriguing and popular fields of knowledge, obsessing the minds of many great academics, as Newton himself, who wrote and was cited in many books on the subject. Newton, as many others, wanted to find the philosopher's stone, a mythical substance that would allow to transform base metals into noble metals, the dream of every alchemist. Nowadays, of course, alchemist methods result somewhat rubbish or laughable, resembling more some sort of sorcery instead of actual science. But with time, alchemy will become more empirical, transforming into what we know today as chemistry. So even if the methods of the alchemist were doomed to fail from the start, its main assumption, the idea that all matter was in some sense the same, so it could be transformed from one form to the other, is actually correct. In particular, let's find out how can hydrogen, the most common element in the universe, be transformed into gold or any other element in the periodic table. Everything that exists is made of atoms, and atoms of the same particles: protons, neutrons, and electrons. The number of protons that an atom has determines which element it belongs to. So, to transform elements from one to another, it should be enough to add or remove protons until we reach the element we want. But this is not so simple. Let's see how we can do this. If we take an atom and we heat it strong enough to remove some protons from its nucleus, we'll end up with a smaller element. This is called nuclear fission. Some elements have their protons attached stronger than others. The elements whose nucleus is weakly bound are called very active. It only takes a slight push to make them react. Other more stable elements, such as mercury, need a stronger hit. You may have heard of this before. Nuclear fission usually produces a lot of energy. This energy is used in nuclear plants to produce electricity, and in weapons, which results in something more spooky. In a nuclear reactor takes place the fission of uranium, which sometimes results in the creation of precious metals as rhodium, palladium, or silver, but in very small quantities. Besides, uranium is more expensive than any of these metals. Therefore, using the fission of uranium with the sole purpose of producing silver, for example, doesn't make economical sense. But how about using something cheaper, like mercury? The Large Hadron Collider is basically a giant cannon in which scientists make particles collide to see what results in these collisions. Here, we could take mercury and bombard it with neutrons to produce gold. In fact, we could theoretically do this with lead as well, fulfilling every alchemist's dream. But lead is a really stable element, so this will be difficult. In order to achieve this, we would need an enormous amount of energy and money just to produce a minuscule amount of gold. Making a gold ring by this method will cost more than $1 trillion. So this might be the least practical way to produce gold. But how about if instead of removing protons to an element, we add them? To know how to do this, we should look at the stars. Literally, stars are basically giant furnaces in which core hydrogen atoms are heated and compressed together until they merge and form helium. This is nuclear fusion, the exact opposite as nuclear fission. Just like in the fission of uranium, the fusion of hydrogen creates a great amount of energy. This is what makes the stars generate light and heat. At the same time, it's what keeps the star from collapsing under its own weight. This is because the pressure from the fusion's energy opposes the star's gravity. When a star gets old, its hydrogen reserves start to run out, so helium takes its place and starts fusing to create lithium. And when these two start to run out as well, the star will create new elements to fuse, each of them bigger than the previous, like carbon or oxygen. But there's a problem. Each new element implies less energy for the star, considering that fusion of heavier elements produces less energy. When iron is formed in the star's core, the fusion reaction stops. Iron is one of the most stable elements. It's impossible for the star to produce energy by fusing iron. When nuclear reaction stops, there's nothing holding back gravity. This is the end of the star's life. All the mass in the star collapses into its core, making it explode. This is a supernova. The energy of this explosion is enough to finish the job of the star and fuses iron into the rest of the elements, like uranium, lead, or gold. The star will become into a dust cloud, made of every single element. With time, gravity will help to form inside this cloud planets, asteroids, and even other stars smaller than the first. This is how our galaxy and our solar system were created. So there you have it, we finally reached our answer. To transform hydrogen into gold, we only need some time and a big star. The stars are the ultimate alchemists of the universe, creating absolutely everything that composes the stuff around you, including you who watches this video. Additionally to being such a complex being, extraordinary in so many ways. Keep in mind that you're also stardust.